Hello, everyone. It's me. We're going to make a stool for a gnome in Gnome, Alaska. AKA, we're going to do the first problem of your notes. There's the picture you can see on the screen. Look at that little guy. Garden gnome. All right. So the idea is the 1 over x squared is basically everything above the x-axis. It was the volcano graph that we did last year in pre-calc, the Atari symbol, whatever we want to call it. But then when we revolve it around the x-axis, we get that little like golf tee looking thing. So basically, perfect thing if you drive the small part into the ground. It is a nice stool for a gnome. So anyway, that's what we're going to deal with. I need some basics. And then we're going to switch gears so you can actually see this. And do a couple of these and then let you guys on your own so that you don't have to listen to me do this entire thing. All right, here we go. Picture. 1 over x squared. Looking beautiful. Okay, here's 1, here's 4, and our region looks like this. We don't want the area, but we're going to draw a frickin' slice. There it is. All right, we're going to revolve this slice. I like to do this. I like to throw the little revolve symbol there. All right, the idea is no matter where you drew your slice in this interval from 1 to 4, we realize that the radius, which is always measured from the axis of rotation to the outer edge of the piece that you're rotating, that has got to be able to change. For instance, if I drew it here, it's smaller. If I drew it here, it's smaller, smaller, smaller. So we need it to be a function. So now we got to rotate a rectangle. If you rotate a rectangle, what shape are you going to get? You're going to get a cylinder. All right, center point right in the middle there. The radius is from here to here. Now, our cylinder is going to be vertical. So ours is going to look like this, hopefully. And the center point, right smack dab in the middle to a point upward here. So now let's just try to get some pieces. The radius is clearly the height of the rectangle. The height of the cylinder is the base of the rectangle. We're going to call that delta x. So if I drew it on all of these pieces here, this is what we're talking about. Okay, so what's the volume of a cylinder? It's extremely easy. It's pi r squared h. It's a stack of quarters, however you want to call it. The pi, r squared, and then rh happens to be delta x because we're taking this vertical guy and thinking about it lying down. Height is delta x, radius is still r. Now, radius in terms of this, g. What do we call a random vertical distance that goes from 0 to some height y that happens to be on the function f of x? We shall call that f of x. So that's what our slice looks like. Pi f of x squared delta x. So therefore my total volume is going to be pretty easy. I'm going to use the integral, which is going to sum all of the volumes of all of the slices from 1 to 4 of pi 1 over x squared dx. If I square 1 over x squared, I get 1 over x to the 4th, or x to the negative 4th dx. And I'm going to get negative pi over 3x cubed, evaluated from 1 to 4, which is negative pi all over 3 times 4 cubed, minus negative pi all over 3 times 1 cubed, which is pi over 3. So this part is minus that number right there. It's 64 times 3, so that's 192. And then you can do the math from there. That was our answer. Cool. Alexa, play Slayer.
Here's a station based on Slayer.
Alexa, turn it up. Good boy, come on in, bud. Settle down. We only got one more quick math problem to do. This is the problem that we did the other day in class. Alexa, stop. So we did this one. We did the same slice before. So this is example 2 of our notes. You can see it's the disc method yet again. It was Stewie Griffin's head. It was the rugby ball when Mr. Modi came in during the 5th period class. 9th period crushed this thing. 5th period did pretty well as well, if I remember. So we're going to set this up. The slice is a rectangle. We rotate the rectangle, we get a cylinder. Volume formula of a cylinder is pi r squared h. Pi. Oh, isn't this convenient? The radius happens to be radical sine x, and we're squaring it. Interesting. So again, if you fell asleep during this video because of my soothing voice, well, it's time to wake up because you're pretty much on your own on this one. We got delta x, that's the height of the cylinder. The center point is going from here to the radius, to the outer edge. Any one of these things is fine. That's the radius. It happens to be the height of the function. If I drew my slice here, it's still the height of the function. If I drew my slice here, it's still the height of the function. So regardless. So our total value, 0 pi. Pi. Radical sine x squared is just sine x. And we're going to get negative pi cosine of x evaluated from 0 to pi, which equals negative pi cosine of pi minus negative pi cosine of 0. Cosine of pi is negative 1. This is going to be pi plus pi, which is 2 pi units cubed. I'm stopping this video right now, I think. Maybe.